Hello, discrete math fans. What I'd like to do is give you a list of often used logical equivalencies. That way we'll be able to refer to them by name in the future. In this list, we'll use a T for a tautology and C for a contradiction. Alright, so these are a whole bunch of laws that we can use. Commutative laws, associative laws, identity laws, laws of the excluded middle. In the last video, we proved this one here, that P or not P is a tautology. And in a similar way, P and not P is a contradiction. So the way you'd prove any of these is by using a truth table. Here's some more. We have a double negative law, idempotent laws, universal bound laws, De Morgan's laws. Now I would say that De Morgan's laws are probably among the most important of these logical equivalences, but we do have a lot of them. Absorption laws, negations of tautologies and contradictions. Alright, so let's use this list of logical equivalencies to prove this logical equivalence. You could, of course, do this directly using a truth table, but that's kind of the messy way of doing it. Alright, so let's start with the left side, which is the more complicated side. That's usually where we want to start. And the first thing we'll do is use De Morgan's law on this first piece here. Then we can use the double negative law. You see we have a not Q. We'll just replace that with a Q. Now we can use a distributive law. So there's a distributive law that we're using in here to simplify the expression. That's because both things on the inside are ands, and they both start with a not P. Then notice that we have Q or not Q. That turns into a tautology. That's the law of the excluded middle. Finally, whenever we have an and with a tautology, we can just drop that piece, and so that gives us not P by the identity law. And that's the final step. All right, so these are a little bit messy, but it's worth knowing all various identities, and we'll have some practice doing this. Okay, that's all for now.